Lesson 7G, regulatory function of the kidneys using aldosterone and pH control. A second regulation of urine formation involves sodium ions in blood plasma. High blood pressure is associated with an overabundance of sodium ions in the blood, often because of high salt diets. If the blood is too salty, then water will enter the blood via osmosis, leading to an increased blood volume and therefore increased blood pressure. The adrenal gland, which is a gland that sits on top of each kidney, also helps with managing blood pressure. When the adrenal gland's baroreceptors detect decreased blood pressure due to low blood volume, then it will release a hormone called aldosterone into the bloodstream. Aldosterone increases the reabsorption of sodium at the distal convoluted tubule, moving more salt into the medulla. This increased osmolarity in the medulla will bring water from the nephron back into the blood via osmosis. This will create less urine, but again will be more concentrated with waste. Once blood pressure returns back to normal, the adrenal gland will start releasing aldosterone, which will lead to less salt reabsorption and less water reabsorption. There will be more urine formed, and it will also be more dilute of waste materials. This control of blood volume due to salt concentration is also an example of a negative feedback loop. Finally, we look at maintaining pH homeostasis through the kidneys. The kidneys help maintain blood pH at roughly 7.35 to 7.45. This is a multi-organ effort. As you will remember, the lungs respond to low blood pH by increasing breathing rates. This results in more CO2 leaving the body, which in turn shifts the blood buffer system to the left, decreasing the amount of free hydrogens and raising the pH. The kidneys help adjust low pH of blood, or acidosis, by excreting hydrogen ions into the urine, or by reabsorbing more bicarbonate ion buffers back into the blood at the distal convoluted tubule. The excretion of hydrogen ions would obviously raise the pH, and the reabsorption of bicarbonate ions back into the blood would bind more free hydrogen ions, raising the pH. For high pH, or alkalosis, the kidneys would increase excretion of bicarbonate ions, shifting the reaction more to the right and releasing more hydrogen ions. Both of these processes are quite complicated and require a number of steps, and the explanation will be avoided at this time. However, regulation of pH by the kidneys is also a negative feedback loop.